This video is about how derivatives affect the shape of a graph, and I'm going to do two questions. This first one is just asking you whether you know the basic rules. You have to know those or you can't do anything. And the second one is applying those rules to sketch the graph of a function whose graph is not really obvious. So here's a fifth degree polynomial. So we'll find where it's going up and going down and things about the concavity and draw a picture of it. Alright, so let's start with the first one here. So how do you determine where f is increasing or decreasing? This is just asking about the increasing-decreasing test, so you should know that f is increasing where the first derivative is positive, and you should know that f is decreasing where the first derivative is negative. Okay, so that's the big thing that makes the that lets you answer question A. And B says, how do you determine where the graph of f is concave upward or concave downward? So remember, this is what concave down looks like, and this is what concave up looks like. And when you switch concavity, you have something called an inflection point. So this is an inflection point, and this is an inflection point, and this is an inflection point. So there's really, three. I guess you could do this backwards too, couldn't you? There are a few ways inflection points could look. So they're points where the concavity changes. You determine where the graph is concave upward and downward by checking the second derivative. So it's concave down where the second derivative is negative, and it's concave up where the second derivative is positive. And C says, how do you locate inflection points? So you have to solve f double prime equals 0, and that gives you all the candidate locations. So why are they not just automatically inflection points? It's because the second derivative actually has to change sign. So you need to make sure that it changes. Look, it can't change concavity unless it changes sign. It has to go from negative to positive, or it has to go from positive to negative. But it can be 0 and not change sign if it has a root that looks like this, like a bouncy root. So if you solve this equation, you get all the candidates, and then you just need to check that it doesn't just kiss the axis like that. That's the answer to part 1. All right. So now we're going to just analyze this function and kind of graph it. So to find the intervals of increase and decrease, we have to determine where the first derivative is positive. So we better take a look at the first derivative. The 5 comes down, this becomes x plus 1 to the 4th power, and by the chain rule you owe the derivative of the inside, but it's just 1. And this next part becomes minus 5. So we set this equal to 0 and solve for x. So this becomes 5 times x plus 1 to the 4th equals 5, and this means that x plus 1 to the 4th power is equal to 1, and this means that x plus 1 is equal to plus or minus 1. So I just took the 4th root of both sides. So that means x is equal to either 2 or 0. No, that's not right, is it? I should be more careful. So minus 1, plus or minus 1. So what are the possibilities here? 0 and minus 2. Alright, so these are the possibilities. So we just found the roots of the first derivative. So those are the places where the first derivative can change sign. And now to know what the signs of the first derivative are for all the points and the real numbers, we just need to see what it's doing on each of these parts. So check each part. So the first part goes from starts at negative infinity and goes up to minus 2. Okay, and so what is f prime doing in there? So the sine of f prime, in this case h prime, sorry I'm saying silly things, you could test that by plugging in, let's say -3 is in there. So what happens when you put -3 into h prime? You get 2 here, right? And this part's going to be bigger, so it's going to be positive. So on this part, h prime is going to be positive. And what's going on in here? Well, you can just test a point, and an easy test point in there is -1. And by the way, we should write that interval. That interval is -2 to 0. So here we got a plus, and what are we going to get here? So plug in -1, and that gives -5 is negative. So this is going to be, on this part, it's going to have a negative sign. So the sign of h prime here is negative. Should make a little divider here. Okay. All right, so that means that h is increasing here, and h is decreasing here. And we just have one more thing to check over here, and a nice test point in that region is 1. So what happens if we plug in 1? We get 5 times 16, so that's definitely going to be positive. And so we should also write that very last interval. So that goes from 0 to infinity, and the sign of h prime is plus there, so h is increasing. Okay, so this table is the answer, and you should try to write it more nicely than I wrote mine. I'm sorry I was so sloppy. So the second part is, find the local maximum and minimum values. So we can read those off from this table. So it goes from increasing to decreasing at -2. So what does that look like? Increasing, decreasing. So there must be a local max at -2. And we could plug that in and see what the value actually turns out to be. And I did that, and it turns out that it's 7. So I'm trying to write on the wrong surface. This turns out to be 7. And what happens at 0? At 0 it goes from decreasing to increasing. So 0 must be a local max. Local min. Because it goes from decreasing to increasing. It looks like this. That's a local min. So that happens at x equals 0, and h of 0 is equal to, what is it, -1 or something? We plug in 0, we get 1, minus 2 is -1. So -1 is a local minimum value. And what else have we got? We're probably supposed to figure out things about the concavity. So to do the concavity, we need to know the second derivative. So let me copy this. I wish I could remember it, but my memory is but a leaky tub, as Blackmore said. Now I'm going to take the second derivative, h prime prime equals 20 x plus 1 cubed. Set this thing equal to 0 and solve it. Clearly the only solution is x equals -1. Alright, so the question is, what happens on these things to the left and to the right of -1? So we just need to test here. So a good test point there is -2. So what goes on there? That definitely makes it negative, right? So that's going to be, on this region, it's going to be negative. And I should write the intervals so that we know what they are. So the interval from -infinity to -1, this is actually the way I want to see it. H prime prime is, we evaluated the test point 2, it turned out to be negative, so H prime prime is negative, which means that H is concave down. Okay, and from -1 to infinity is this region. We need a test point here, so let's use 0 as a nice one. And if you plug 0 in here, it turns out to be positive. So here H prime prime is positive, and this is concave up. Okay, great. And so it turns out that -1 is an inflection point. Now we have to graph it, sketch the graph. Okay, so let's try it. So here are some axes, and we know some special points. We know that a local max happens at -2. So here's a local max. And we actually know that the function evaluates to 7 there. So it's going to look like this around there. Oh, that's terrible. Okay, something like that. And we know that 0 is where a local min happens, and the local min is -1. So -1 is going to look kind of like this here. Okay, and we know that it has an inflection point at -1. Inflect. So we figured that out right there, right? Remember? And what else do we know? Not much. That's enough to draw a good picture. We know that it's increasing from -infinity to -2. Okay, so it's increasing that whole time. Also, I know that it's a 5th degree polynomial with a positive leading coefficient, which means that its general shape is like this. And I know people still stare at me like when I say that, but you really need to figure out what that means. All odd degree polynomials look the same. So talk to me or figure out what that means one way or another. It's a pre-calculus thing. Alright, so now I just need to connect all this stuff. So it comes here down from -infinity and connects up sort of like that. And I guess I need to turn off my, oh, that looks good. I'll turn that thing off. Comes down here. We have to inflect at -1, so that's where the concavity should change. I know my picture's not perfect. This drawing surface is kind of hard to draw on. And then it wants to go back off to positive infinity like that. So this is the graph, y equals h. And it's a pretty good graph. And that's it. So I graphed it using foodplot, and you can see that it's pretty much right. So that's all. Oh no.